Thank you for joining today's webinar. Once again, my name is Jenny Hu, and I'm the Head of Customer Success and Growth here at STARLIMS. I will be driving the conversation and asking the questions today. And it's great to have you all here. I'm really excited to actually dive deeper into today's topic. Before I got into tech, I spent a few years working in various labs as a biologist. And till this day, I still remember the time spent on trying to reproduce an experiment with a protocol that was on this crinkly piece of paper with annotations in the most cryptic handwriting I've ever seen. And in the end, without any surprise, I failed and had to start from scratch. So trust me, I've been there when it comes to the replication challenges we all face. It's actually a big part of what motivated me to start working with other scientists, to help make their research experience better through technology. And speaking of scientists, joining me today, we have Uraisha Magan, the R&D lead at Newform Foods, and Youyou, assistant professor in psychology at University College London. To provide some background, R&D and science at large has been grappling with a replication crisis where positive results of experiments can't be reproduced. This leads to billions of dollars lost each year. And our discussion today will delve into the origin of the crisis, its impact on innovation, and how scientists in the R&D labs are handling these concerns. Our speakers today, Uraisha and Youyou, they bring a wealth of knowledge and experience on this topic, especially giving both academia and industry perspectives. They have a lot of insights to share, and we will also have a live Q&A at the end of our chat. Super excited. So to start off, can we have each of you introduce yourselves, Youyou and Uraisha?
Yeah, thank you, Jenny. For the invitation. I am a psychologist at University College London Institute of Education. My primary research area is in personality psychology. I study how people express their personalities in digital environments. But throughout my work, I've always been drawn to meta science and methodology, and particularly reproducibility. I'm now doing work on trying to predict replication outcomes before a replication study takes place using different methods.
Amazing.
Cool. Okay. Thanks. Thanks, Jenny. So as you said, I'm a scientist. I have a background in microbiology and biochemistry as well as biotechnology. I have worked over 13 years in the R&D space, over academia as well as industry. So I am no stranger into the replication challenge, especially in the scientific context. Currently, I am the lead at Newform Foods, which is a cultivated food meat platform technology. And I look forward to discussing the replication crisis today.
Very exciting. I guess, let's jump right in. So Youyou, you are the co-author on the article Kellogg Insight on how AI can help researchers navigate the replication crisis. You talked about a 2016 poll of 1,500 scientists that showed that majority believed science is undergoing a replication crisis. It is estimated that replication failure is the source of over $20 billion in losses across science and industry each year. Which is insane. So I guess, could you begin by explaining the replication crisis for our audience and share how you first became aware of the issue?
Yeah, so the replication crisis refers to a big challenge in science that empirical studies often fail to replicate. So in other words, if you repeat the same study, you will not get the same results, and that's a replication failure. And this raises the question of how much we can still trust the research findings we see in publications, in journals. And this problem is present in many different disciplines: psychology, economics, biology, medicine. And so I would say literally every empirical discipline is concerned with this problem. And I first became explicitly aware of this issue in 2015, I think, when a large-scale replication project was published in the journal Science in my field, psychology. So the researchers were trying to replicate 100 psychology studies, and they discovered that the majority of them, about 60%, were unsuccessful replications. And that was, for me, a watershed moment, and that drew a lot of attention in my field to the replication crisis. Although before that, many scientists, including myself, had suspected this is a huge issue. We have all seen in our own practices how this is manifested, like why there are so many what we call researchers' degree of freedom that could lead to your studies not being replicated successfully. But this study, this science study, was the first one that provided concrete evidence to the magnitude of the problem.
Yeah, I mean, 60% is a very high failure rate. It's actually shocking. Why is the ability to replicate experiments so fundamental to scientific progress? And what do you think are the current effects of replication failures on academic research as a whole?
Yeah, so replicability is, I would say, the bedrock of scientific progress because of two things. First, because of its practical importance, and second, because of the cumulative nature of knowledge production. So in terms of practical importance, we all trust the medicines we take, the bridges we walk on, because science has demonstrated that they consistently work. So that's why we care about replicability. But even when a piece of finding or knowledge is not immediately applied in real-life contexts, it's still important that it's replicable because other scientists or practitioners will build upon these discoveries to do further work or interventions. For example, there might be drug developed later on for humans based on principles discovered among animals. So we do care about replicability at every stage of research and knowledge discoveries. And the negative effects of irreproducible research has been tremendous. As you said, just to clarify that, the $28 billion a year wasted on is mostly just the preclinical research in medicine. So I think if you consider every discipline, there will be a lot more. So yeah, there's lots of money and funding wasted on research that's not replicable. So that can very much delay interventions, drug development. And more specifically, an example in my field of social psychology, we have a key experimental paradigm, a key concept called priming. And priming occurs when something you see can subtly influence your perceptions, like seeing a stack of money will make you feel rich. And that's an experimental paradigm where we use across the entire field for different purposes. And there's evidence that this effect is not replicable, and that will negatively affect so many experiments that we do in our field that rely on this effect working. So it's imperative that we care about reproducibility and continue to improve it.
Yeah, I definitely agree. There really seems to be this cascading effect that amplifies the problem as we go. And I guess from your research, what are some of the underlying causes that you believe to contribute to this?
Yeah, so I believe the primary cause of replication failures is the prevalence of what we call questionable research practices. And these are practices that often involve manipulating data or tweaking research design to achieve positive or favorable outcomes. And they are surprisingly or alarmingly common. And a recent survey in 2022, I think, indicated that over half of the researchers they surveyed acknowledged to be engaged in these practices at some point. And then if you ask, why do scientists so frequently do that? And then the answer is a flawed incentive structure. Like academic promotions often rely on or hinge on publishing in journals. And you have to publish multiple articles a year in high-profile journals, and the journals prefer strong positive results. It's really hard to publish no results even these days. And given the limited resources and time researchers have, they can't afford to conduct experiments and not get their desired results. So this pressure makes them prioritize positive results over rigorous methodology. And this contributes substantially to the replication crisis. And just to compare that industry researchers are often more driven to produce reproducible work because often their research is directly implemented in the organizational context and their performance is measured by tangible outcomes or revenues generated. So really these different incentive structures could lead scientists to different behavioral patterns and then eventually contribute to this overall crisis.
Yeah, that's super interesting. Especially you highlighted, the lack of data integrity to be one of the primary causes. I guess, could you elaborate a bit more on that particular point? Like, how does the data quality itself influences the replicability of science studies?
Yeah, so data quality is crucial because lots of noises and biases could be introduced in the data collection procedures, intentionally or unintentionally. And I can give you 2 examples. So first, we as researchers, we should always plan ahead how much data we are collecting and justify it and stick to that plan. And one problematic practice is to peek at your results midway. When you're collecting data, you're analyzing and see the results at the same time. And then sometimes researchers, they stop collecting data when they see positive results. They're afraid that collecting more data would change their results. And that's one problem. And another problematic practice is during the later data analysis stage, researchers would can decide to remove certain data points. And at that point, a problematic but common practice is to remove data or transform data to skew the results favorably and only rationalizing the decisions after the fact. So these are problematic practices that lead us to data that are not that would not speak to the truth of the findings.
Yes. Yeah, thank you, Yo, for the fascinating insights and some of the data that you provided. It's really shocking to me myself because obviously I don't read up on this on a day-to-day. So some of these numbers are definitely more than I expected. And being so candid on some of the underlying issue with also data handling processes in academia as in general. You mentioned industry researchers might be more incentivized to produce reproducible results. I guess this might be a good pivot for Uraisha, yourself being working in industry for with a lot of experience there. Could you expand on the relationship between academia and industry and how the replication crisis plays out there?
So definitely, I mean, in biotech, which is my space, we rely on fundamental research findings that are found in publications. Any biotech or novice kind of scientific company will use manuscripts and publications for basis, or the information found in them will be the basis of their products or innovation technology, or even recipes or processes. So definitely in terms between academia and industry, I think the common consequence of the replication crisis is the loss of time. As well, in industry, the bigger loss is money. And industry, for example, in a startup, cost is a big factor to have products based on science that are not reproducible. And that could lead to many other consequences, such as, the reputation of the company going down, the loss of customers, as well as investors. People investing in the biotech will pull out because the science is not reproducible. I guess also in terms of academia, similar things like postgraduate students spending a lot of time not knowing that their results, the results are not reproducible. They kind of like, their morale goes down. So obviously researchers in industry also feel that, where they blame themselves because things are not working out, but it's actually because the science is not reproducible. So it has big impact on industry, especially if the industry relies on the income, or the product is the income that's relied on the science, should I say.
Yeah, I mean, great response. Cost and resource and time loss is such a key factor that hinders progress in, I guess, both academia and industry. So my follow-up question to that would be, in what ways have you observed the replication crisis affecting your work, whether it's in academia or in your industry roles?
So in both, as for instance, in academia, I did try to replicate by growing cells that were supposed to mimic an intestine. And I spent 11 months trying to grow these cells, and it just didn't grow. It just didn't work. And I read publications upon publications. And the funny thing is that a lot of the publications, the methodology sections were kind of like the same. Like you would think that these people have been doing it, it's quite a routine thing to do, but it really, I couldn't replicate it. And I was thankful that my PI or supervisor pivoted me in another direction, and I was able to complete the study. I just couldn't publish because, as Youyou mentioned, you can't publish no results or negative results. So I was able to write it in my thesis, but unfortunately I couldn't write it. I couldn't publish it. And in industry, I was producing a probiotic strain, and with different strains, like it's very important when producing biological materials in industry to have a consistent production process, because at the end of the day, you require the products to be the same, or each batch needs to be like the same as the previous batch. So if we couldn't produce something, we would rely on literature or publications to help us troubleshoot. And it took us months to get it right. In fact, we had to basically modify our process. Based on these modifications, we were successful, but we did lose a lot of time relying on insights from publications.
Yeah, I mean, wow, like that's just, I can totally relate in terms of the gone through for the cell culture component. Like I've done cell culture. I know how devastating it is when you just keep getting negative results. And yeah, that I can totally empathize with your experience. I guess a bit more to current times, can you provide some specific examples where some of these replication challenges have impacted your current projects in your job?
So currently I am in the cultivated meat sector, and it is quite a novice sector. So there's not really much information out there. So we rely on whatever information is on there. So the biggest issue we're having in this new sector is like scalability of the products, but in terms of information found in the public domain is really scarce. But on the other hand, there are a lot of methods that are published that's on isolation of these cells in order to make the cultivated meat. However, they differ from species. So if you're using fish, for example, versus lamb versus beef, sometimes you cannot, it takes a lot more time and rigor in the experiment, and you have to kind of modify each thing. So it's not just a recipe that you can replicate, and you have to like really rely on your own ability as a scientist in order to produce these cells, because at the end of the day, if you don't produce it, you're not going to get the product. So as Youyou touched on a primary study that's built, other studies are built on a primary study. These are kind of like the isolation of cells are like the building block of your product. So if you don't get that right, then you have no product at the end of the day. So definitely we've experienced differences in the different species that we use.
Yeah, it just seems to me that it's really clear the challenges are very systematic or systemic, where it spans across multiple industries. No matter whether it's novel or it's been around for a while, we do suffer a lot in the sense where the crisis does affect in every single stage, and it cascades. So I guess based on your experience, what measures are R&D teams implementing to address these challenges? Like you said, it affects results, investors, it really impacts the business. So how do you combat that?
So I think the most important thing is clear and concise documentation of all experimental work done. I think, it's very important to have even failed experiments written, because there's lots of learnings in that. The second thing is transparency within your team. All outputs written from your experiments should be shared. You could use platforms such as Google Drive or shared platforms where everybody has access to your research as well as your outputs, as well as your failures. If they ever need to replicate their stuff, it's shared among your entire R&D team. If people use lab books, we always have them numbered, and be sure when people exit they return their lab books so that, we can keep the information that was done by the employee or student. I guess that also spans into academia as well. And I guess like in science, the generic things to have, independent experiments will have to have their own replicates, has to be, the protocols have to be written concisely, as well as, using statistical analysis always to interpret data. Like, I think that will really, obviously sorry, my earphones fell off. That obviously has an effect on the data that is presented.
No, all good. I mean, yeah, thank you so much. And it's great that you brought up the documentation of data. Drawing back to what Youyou mentioned, there seems to be sort of resemblance in some of these ways to combat the challenges, and how data quality plays such a key role in replicability of research. Also knowing statistics such as having an average delay of 3 weeks before performing an experiment and documenting it. It does highlight how critical it is to have a more structured approach in just data capture and having more transparency to help with collaboration amongst teams. Yeah.
Yes,
I guess
and
pivoting
on that,
sorry, yeah.
Sorry, I forgot to mention, in industry specifically, we rely on standard operating procedures. So basically on procedures that have already been tried and tested, we write down, and every single person is kind of trained on them so that, you create a redundancy in your team. If somebody's sick, somebody else can do the work, as well as we have a good GLP system, which is good laboratory practices, and a good QC system.
Yeah, and it's great that there's more toolkits available for scientists now to be able to really standardize their approach of version control, having that audit trail. Pivoting a bit on that, despite of all these advances in technology, obviously to aid in documenting research, standardizing your procedures and all that, and sharing, being in this digital world, but replication issues are still arising. So why do you think documentation alone isn't solving these problems?
I guess for me is what people document. Like in scientific practices, there's lots of techniques involved in the manner in which you do things, and that's never documented in any publications. There's nuances to each way in each experiment, and that's always left out. There's huge gaps that nobody publishes. And the biggest thing for me in documented or published manuscripts is that nobody presents negative results and what went wrong with the failures. Everybody presents a polished, positive, tried and tested method that kind of like, it gives a false hope that this thing took a week or 2 weeks to do, but in actual fact, it was months. And I think another thing that documentation doesn't address is the environment. Each lab is different, and I think that's a big thing to consider when replicating experiments, that some environments will not be conducive. Like if you are, for example, if you're replicating an experiment that was done in a high-tech lab that has all the tools that it needs to maintain a constant environment, and you're trying to do it in your lab, that's a startup lab that doesn't have much resources, then it probably wouldn't work.
Yeah, I mean, I totally agree. And I guess given all the challenges you've mentioned, of the above, I'm just really curious to know, is Newform Foods tackling this within their projects as a startup company with limited resource? What are your approaches?
Yes, I think Newform is excelling. So the biggest thing for us is that we use Labstep ELN from STARLIMS. That is basically a online platform tool where all your experiments, all your data sets, all your protocols, as well as inventories is stored in one place. So the entire R&D team uses that as a tool. The key thing is that it has to be managed, because people are not diligent in using the platform. If they're not used to it, they'll still use lab work. You have to kind of implement that everybody uses the platform so it works. We do a lot of other things I've mentioned, like we train all our staff, like cultivated meat. the biggest experiment is like tissue culture. Like a lot of the tissue culture spans all departments, so everybody needs to be well equipped in the knowledge of it and be able to grow cells from scratch in a sterile aseptic environment. So that is taught through the entire R&D team. We also, as I said, we have standard operating procedures for all defined processes, as well as a good quality control system so that every single product is measured and we have the same thing coming out. So things that's going to investors or out to the public is tested. We also have everything is online. We use a project management system that's online. We share, like nothing is ever saved on a desktop. We use Google Sheets, we use Google Docs. So, and everybody has, there is a culture of transparency within Newform where everybody has access to things. And if you are working within the team, you can look for things if the person isn't there. So yeah, I think we are trying our best. And also we get our protocols reviewed so that, you know, it's robust, and we have our SOPs verified by other people so that you can see that they can repeat the experiments. So yeah.
Amazing. Wow. Well, thank you for the insights, Uraisha. It's really great to hear a company like Newform Foods really, you know, putting the processes in place to enable their scientists to do the work and helping, you know, combat some of the challenges we face. And, you know, you made a point in the previous question that I really strongly resonate, is that you said around the learnings from all the data outside of a polished experiment report, right? A lot of times this is not accessible, and this is where we actually need to hone in and study and learn about. There's this famous quote, you know, it's not the destination, it's the journey itself. So replication becomes difficult as most of the time we don't get the full picture of the steps it takes to get to the results itself, right? That's kind of the situation. So, and thank you for that insight. I guess the next part of my questions are for you both. It's on more navigating the challenges of replication itself. So what are some strategies you would each of you recommend to our listeners today to focus on in terms of improving replicability in their own research?
So I would just reiterate some of the facts that I have stated. For me, documentation is everything, the good, the bad, the ugly. I think that is very important, as well as to have experiments that are robust with multiple replicates and interpreted with stats. Using platforms like Labstep from STARLIMS to keep the research and development in one place. Also to try and incorporate as many online shared platform systems as you can. Shared skill development, training other staff members on the experiments so that we're not relying on one person. And yeah, I definitely believe that protocols with robust information will help in keeping this replication crisis at bay.
Yeah, so Uraisha shared a lot of valuable tips, actionable tips, and I would like to highlight some of the advancements in incentives when it comes to producing replicable research and academic research. So if you're an academic, I would suggest that you consider using what we call registered report format for publishing your work. So this is a research article format that would enable you to submit your study proposal for review before any data collection. And the decision to accept your proposal or your article being published in the journal is based solely on the strengths and the rigor of your research design. And this will take away the pressure, hopefully, to produce positive outcomes and reduce the temptation to engage in questionable research practices. And this will allow you to publish no results because journal is committed to publish it regardless of the results. And this format is available in many top journals, interdisciplinary ones. And even more recently, there is this community called Peer Communities in Register Report that allows you to go through this whole process with crowdsource, like within your peer community. So not even going through any journal protocols or procedures, but a lot of journals have committed to accept your article as it is if you go through these procedures in a formal way within that peer community. And this will largely reduce research waste, allow people to be less engaged in questionable research practices because there's no reason to do that. And I have a collaborator. He's a psychology professor in University of Hong Kong. He has fully committed himself and his students to that. And according to his words, the rejection rate of his research went from 70% to 0, once he started doing research this way. So yeah, I think that's something everyone should consider doing. And if we could all be more embracive of this approach, then I think replication failure rates will go down definitely over time.
Amazing. Yeah, it's really great to hear kind of both the industry and academic perspective on this. I guess in what ways do you think collaboration between academia and industry can also further the improvement of replication research?
So I believe this is the way forward, and industry collaborations can support the replication efforts by independently validating experiments that come out of academia. And these findings can be replicated in real world settings. This process kind of validates the science and gives credibility to the research that's done in academia. Also, I think industries, for example, in a startup, sometimes we cannot afford the expertise like a senior scientist or lead engineers, and collaborating with universities allow us to harness that expertise working together. And sometimes industry doesn't have time to do fundamental experiments that a postgrad student or honor student could do. So it would help to have some of the research checked in academic settings where the research is much more rigorous and there's time for a project. And I think academia could also benefit from sending some of their students as interns to industry partners so that they have real world experience. And yeah, I really think this would help a lot.
Yeah, so besides just expertise, industry obviously has access to more resources like bigger data sets, larger participant pools, advanced cutting edge technologies, equipment, and funding. So it'd be great if the industry partners could share those resources to enhance the robustness of research. And also, as I said, because of incentives, bringing an industry partner into your research projects just often inherently boost accountability for more robust, replicable research that actually work.
Yeah,
and funding opportunities as well.
Exactly. Yeah.
Like when there's collaboration between industry and universities, the funders are more likely to fund a project.
Yeah, just creating more opportunities too. And I guess on that note, Youyou, this is that final question for our session. Really, it's what do you both see as the future of science then?
Yeah, I see a lot of progress already in making sure the science we do is reproducible and trustworthy. We have good infrastructures and practices developed and popularized in the past few years. There are pre-registration platforms to allow researchers to specify their research plan and hypotheses before data collection, so we don't easily deviate from them based on the data received. There are also platforms to publicly share our data and procedures so that other people can verify what we've done. And many journals have adopted more stringent standards when evaluating research. And we have seen many examples where these changes have made real differences. Mistakes are openly identified and corrected. So I think interestingly, this level of scrutiny or transparency, that was what when I first joined the research community, that's what I initially assumed to be the standard in science. Even before I started my career, like when I was in school, that's what I assumed every scientist does. That's why we trust science. It was only after that I started to be engaged in the field that I realized that, oh, these practices were not so common. So seeing these changes, these infrastructures being built, practices being improved, and that gives me hope that we're on the track of steering science back to what most people, myself included, originally expected of it.
Yeah, definitely. I also agree with Youyou, and I think the fact that this crisis has been identified and we have webinars like this to educate people, I think it's a big step, because I don't think a lot of nations actually know that their results or their experiments going forward is because of this. So I think just being aware of it is a big plus. And I also do see a lot of collaboration. Being in industry, we have a lot of university partners with various different aspects of our research. So people are no longer working in silos, or those silo type institutes are not really being favored. So there is a natural shift in kind of collaboration and transparency in work. And yeah, so I do have hope. And like for us in the biotech industry, we do rely on a lot of collaboration within the network of people that we know.
Amazing. On that positive note, well, thank you both for such an insightful conversation. I think we're at the time mark now to just turn it over to Heather for the audience Q&A.
Okay, let's see. I'm going to read some questions that we have. Jenny, how can the Labstep ELN from STARLIMS support researchers in improving reproducibility?
Yeah, that's a great question. I love how the first question was to me. But, you know, Uraisha actually mentioned a few very good points in terms of how having a digital system like the Labstep ELN really helped their scientists and their team to standardize their procedures, maintaining best practices, having a good audit trail of their work. And most importantly, it is this collaboration piece, right? Science doesn't occur in silos. So it's important to have the data captured so that it's not just that final report. It's not the polished version of the science. It's every little step that you take. It's all the metadata that you capture on the way, little deviations that you make in your experiments, so that the next person that comes to replicate that will be able to follow the method and can see, you know, what are what's the journey, what's kind of the lineage of everything that happens in the experiment itself. So I guess, Uraisha, do you have anything to add to that from your experience using an ELN like Labstep?
Yes, I mean, the biggest thing for us is people who have left the company that did experiments on Labstep. We have all that information, and we really don't need to struggle with like old lab books or like pieces of paper. We basically can replicate things that have been done in the past with people we've never met. So and also the best feature for me is that it's linked to inventory. So it does make a lot of like planning for experiments much easier, because there's things, it alerts you when we've reached thresholds of consumables that we need. So it's a very user-friendly, helpful tool for us. And yeah.
Amazing. Thank you for that.
Yeah. Okay, the next question. There must be so many attempts to reproduce academic research with industry, but is there any way we can incentivize industry to publish these attempts?
That is $1 million question, because I do know in industry, sometimes we can improve processes, but publishing it will kind of lose your competitive edge, should I say. But we do try to find a way to publish, because publishing as a biotech or a biotech industry helps us, because it basically shows that our science is credible. But it is difficult because a lot of our IP is involved, and we try to find a way to publish maybe processes or methods without actually giving away IP. So it is a tricky one, which we are trying to balance, but it's not there yet, I guess.
Yeah, I think even besides in social science, where there's not so much concern about losing competitive edge, it's still very hard to publish because companies are concerned about if they publish, they might have, there are some PR risks, and there are some concerns about whether that brings anything in, like is there any benefit in publishing it? So I guess besides the concerns for competitive edges, there's the question is, can we make publishing easier for everyone? Can we make, regardless if it's an industry partners or like a student who independently verify the results or fail to do so, can we make it easier to share the results rather than going through the whole peer review and journal acceptance procedures?
Okay. What do you all think is the difference between research practiced 100 years ago and now?
Yeah, so one key difference, I have a collaborator, he actually studied it, is that 100 years ago, it's more of an individual effort, and now it's more of a team effort. You can see, even judging just by the team size of Nobel Prize winners in the past, it tends to be one individual dedicated to a field. Now it's like multiple individuals. So, and that has implications for reproducibility. And you would think that having multiple people on the same team would have the benefit of cross-checking each other. But in fact, we have seen a lot of time this is not the case. As scientists, for example, often in my field, one person collect the data, and even his or her collaborator does not verify the procedure or verify the integrity of the data. So I think we should now leverage the fact that we have internet and we can make everything more transparent and open. So together as a team, both in terms of your small research team and as a discipline, the bigger team as a discipline, we can much more easily verify and access each other's research and make sure that we verify other people's work and voice our concerns or have discussions around it.
For me, the biggest thing for 100 years from now is basically technology. Now we have AI that can verify so many things that, I mean, we just didn't. And as Youyou mentioned, collaborations, it's so possible now to collaborate with someone across the world. Whereas obviously before, there was just no means to do it. So definitely technology. And in science, we can do so many better experiments based on the tools now available to us. We even can use computational methods to predict the outcome of an experiment without spending that much money to do the actual experiment. So there's a lot of, I mean, technology has made our lives, I guess, much better.
Okay, do you foresee improvements to the replication crisis in the near future?
Well, yes, I feel like as the future of science, because we're kind of changing behavior, making people aware of the replication crisis and implementing, processes that ensure that the science is credible. I do feel like there will be an improvement.
Yeah, as I said, we already have good infrastructures and practices there, and they are waiting. They're slowly rolling out. A lot of people are already on board. And on top of that, I think what we need in addition to that is a paradigm or a space or some infrastructure for criticism. I think what comes along in the replication crisis inevitably is a lot of criticisms against research done in the past, against individuals to engage in these research, and we need constructive criticisms to move things forward in a more systematic way.
Okay, Uraisha, you mentioned the importance of documenting failed results and experiments. Can you clarify and expand on this point?
Well, I think giving the reader an inclination that the experiment that we're doing is not so straightforward. I feel like maybe in a way, if we add timelines or something to the protocol, like, a plus minus 4 months, or maybe some sort of negative results that we've gotten would prevent us going through the same journey of negativity to get to the actual protocol we want to do. So I'm not sure. I haven't actually experienced any journals that accept negative or no results, but I feel that would help a lot with the replication crisis. So yeah, maybe if there's a way we can maybe add timelines to it, or a level of hard difficulty of the technical work.
Could you discuss continuous improvement as a business process in the normal course of successfully competitive business processes?
We often have like methodological ways or systematic ways of doing things. Like, everybody goes to the tissue culture training in the same way. There's standard operation procedures for our methods. There's a lot of checks and balances where we can make sure everybody is kind of repeating the process. And for instance, in production, we get to a point where we are producing the same yield time and time again. So it gives us confidence in the science that we're doing, where our results are always the same as the lots.